for this problem, we have weight hanging from a spring. And in the first case, it has a potential energy of 2.30 joules. And then we replace this block with a block of a different mass. And the masses are given. First mass is 6.74 kilograms. Second mass is 1.38 kilograms. We want to calculate what the second potential energy is. Now, we can put in the forces. We know what the spring force upward in both of these cases and the weight force acting downward. We have two different stretches in the spring, x1 and x2, because we have two different weights. Now, this problem is going to be more of a manipulation of formulas problem. 3 equations, 3 unknowns kind of thing. We'll start off by just typing in the equation for potential energy. So let's say potential energy in the first case is equal to 1/2 k x1 squared. Now, we have the same k in both of these cases because it's the same spring. So I only have to put k and not k1, whereas I have to put x1 because the stretch in the spring is different. Now, I'll call this my first formula. Now, I'll write potential energy in the second case, which is what we want to find out, is again 1/2 k x2 squared. I'll call this formula 2. Now, we need to basically substitute for k and x2 in order to figure this out. So let's figure a little more of what we know, type in another formula. We'll do sum of the forces equals 0. Okay, so we have force of the spring, positive direction, minus weight equals 0. So basically, we say Fs equals weight. And the force in the spring is Kx, which is equal to the weight of mg. Now this is going to be for either one of these. It doesn't matter. This formula holds for both of these cases, block 1 and block 2. Now, what I want to do is solve for either k or x and plug back into these two equations. Okay, and I'm going to choose x to solve for and plug in, because what that's going to do is that's going to leave me with an equation just in terms of m, g, and k. And when I plug that in, m and g are known. We know the masses and g is a constant, and k is the same in both those, so that we can get rid of the dependency on x1 and x2, which we don't know a relationship between. So x equals mg over k. Now, I'm going to call this equation 3, and this is going to hold for either one of these, so I'm going to plug this, number 3, back into equation 1 and equation 2. Okay? So I'm going to plug in 3. Maybe I'll just put it here. 3 into 1 and 2. Okay? So basically that's going to give me potential energy 1 equals 1/2 k, and plug for x squared is going to mg over k, m1 g over k. m1 because I'm using it in the first block equation squared. Okay, and if I do this again for 2, we have PE2 equals 1/2 k m2g over k squared. Okay. So what I can do now is I'm looking for potential energy 2, and the only thing I don't know in this formula is k, and it's not going to quite cancel out because we have k squared here and k here. But in this formula, I have potential energy as a number, m as a number, g as a number, and k. I can actually solve for k here and figure out a value and plug that in here. Okay, so if you want to do this, you can actually solve k for an actual value in newtons per meter and plug in here. I'm just going to solve it in terms of the equation. Okay, so I'll just write this back up here. So I'll have PE1 equals, I'm going to say that's 1/2 k times m squared g squared over k squared. M1 squared g squared over k squared. Okay, simplify that. So basically, I cancel out one of those k's, so I'm getting m1 squared g squared over 2k. Okay, now I want to solve for k, because that's what I'm going to plug back into here. I could equally just solve for k and have a number, plug that number into here. I'm just going to use it as variables. K equals m1 squared g squared over 2 potential energy 1. I just multiplied both sides by k, get rid of it here, put it up here, divide both sides by potential energy 1 to get it down here. So I'm going to call this 4 and plug this back into this potential energy 2. So PE2 equals, okay, so I have M2, I'm going to square this out and leave this 1/2 on the bottom. So one of these k's is going to cancel. I'm going to do some simplification right here in one step. So I'm going to have M2 squared G squared over 2k. I only have 1k because I've canceled it with one of these top k's, just like I did before. So this is exactly like this now. I'm going to take k and plug it in here. So PE2 equals m2 squared g squared over 2. K is now m1 squared g squared over 2 potential energy 1. Okay, all I have to do is simplify now. So this becomes m2 squared g squared these 2's are going to cancel out. This potential energy 1 will be flipped to the top, divided by m1 squared g squared. So now the g squareds cancel out. So potential energy 2 equals m2 squared over m1 squared times potential energy 1. Okay, we know these numbers. We can just plug these in. Equals m2 is 1.38 kilograms. Squared divided by m1, 6.74 kilograms. That's squared, multiplied by our initial potential energy of 2.30 kilograms. 2.30 joules, sorry. So our kilograms are going to cancel, and we're going to be left with units of joules. So potential energy 2 equals, after solving and rounding, is 0.096419, which is 9.64 times 10 to the minus 2 joules. And that is your final answer.